This is the pulse propagation and dispersion lab, and the setup for this is you have your pulse or your signal generator with a square wave, which you can see on the oscilloscope, that is also connected to this transmission line right here, and there's a little connector at the end so that you can put different loads on the line. And you can see in the oscilloscope we have the transmitted wave here and the reflective wave. So this effectively is an open load, since right now there's nothing attached to the load. And so you can see that there's a little bit of loss in the reflection just because some of the frequencies aren't reflected back as well as others. And your set of loads are right here. This is the short load. It's yellow and there's just a wire between it. The open load is just nothing on it. And the 10 ohm, so the little resistors are connected, so if you're not sure what the load is, you can always figure it out with that. Here's the 24 ohm, the 50 ohm, looks like this, and it says 50 ohms on it, and the 100 ohm is this one. So when you attach a load, for example, I'll attach the 24 ohms. There's a little notch in here that fits onto the connector, so you shove it in, and then you twist it to slide it down, and then it kind of clicks when it's in there. And then now you can see this is the reflective wave, and you can measure the reflection coefficient by looking at the ratio of the transmission and reflected wave heights. So when you connect the 50 ohm, for example, since the signal generator has a internal impedance of 50 ohms, there should be nothing reflected because it's matched. And you can find out the length of the line by measuring the distance between the reflected and the transmission waves.